All right, let's talk about something we see every single day, but probably don't think twice about. That perfect, glossy finish on, well, everything. From our cars to our phones. Today, we're going to dive into the invisible science of how AI is making that flawless shine a reality.
I mean, really think about it. That seamless mirror-like gloss on a new car, or the tough, smooth coating on your phone. Getting that right not just once, but millions of times over, that is a massive engineering challenge. But what if you could perfect that finish before a single drop of paint even leaves the can?
Well, a big piece of the magic is a process called in-mold finishing. Now, instead of painting a product after it's made, the coating gets applied right inside the mold itself. This makes the surface incredibly durable and high quality, but man, it requires absolute hair-splitting precision.
And that precision? That's the hard part. Manufacturers are in this constant battle against stuff like uneven coatings, tiny hidden bubbles, or microscopic stress cracks that can ruin the whole thing. And for decades, the solution was basically just trial and error, which, as you can imagine, is slow, super expensive, and creates a mountain of waste. There has to be a smarter way, right?
So here's how we're going to break it all down. We've touched on the problem. Next, we'll look at AI's virtual crystal ball. Then, we'll see how it finds the golden recipe. After that, we'll meet the real-time robot brain. And finally, we'll see why this all leads to smarter factories and just plain better products for all of us.
First up, using AI to see the future. The biggest headache in applying coatings is that you're dealing with all this complex physics. Fluids moving, heat spreading, things that are totally invisible to the naked eye. So, step one in controlling the chaos is to make the invisible visible.
And this is where the amazing concept of a digital twin comes in. The whole idea is to build a perfect virtual copy of the entire manufacturing process right inside a computer. This lets engineers run thousands of experiments, tweak every possible setting, and see the results instantly, all without wasting any time or materials in the real world. It's like a hyper-realistic video game for engineers.
And there are two key tools in this virtual toolbox. On one side, you have CFD, which stands for Computational Fluid Dynamics. Just think of it like a super accurate weather forecast, but instead of predicting rain, it's predicting exactly how a liquid coating will flow and spread. Then, on the other side, you've got FEA, or Finite Element Analysis. This is more like a digital stress test, making sure the final hardened surface is strong enough and won't crack under pressure.
And look, this isn't just some far-out theory. We have research from scientists like Du, Wang, and Zheng showing that these CFD models directly help engineers tweak things like spray speed to get a much more even coating with way fewer defects. There's a direct line from the virtual simulation to a better physical product.
Okay, so the simulation is our crystal ball. It can show us what might happen, but with potentially thousands of different outcomes, how in the world do you find the absolute best one? Well, that brings us to our next step, finding the golden recipe with AI.
This is such a crucial difference. The simulation lays out the entire map of possibilities, but optimization, that's the AI navigator that scans the whole map and instantly tells you the single best route to your destination, a perfect finish. It's the difference between seeing 1,000 choices and knowing the one right choice.
And one of the coolest ways AI does this is with something called a genetic algorithm. And yes, it is exactly as cool as it sounds. The AI basically runs a digital version of evolution. It takes a bunch of different settings, breeds the most successful ones together, and gets rid of the failures, over and over, until the settings literally evolve into the perfect golden recipe.
So this optimization loop is really the engine driving everything. The system runs hundreds, maybe thousands of different simulations. The AI algorithm then crunches all that data, figures out what worked and what didn't, and bam! It identifies the absolute best set of settings to use in the real-world factory. Okay, so we've planned the perfect coating in this perfect virtual world. Let's be honest, the real world is messy. Things can change in a split second, and this is where we have to go from planning to reacting with a real-time robot brain powered by machine learning. The way to think about it is this. Simulation and optimization gave our system a brilliant game plan, but now machine learning gives it the senses, the eyes and the reflexes to actually execute that plan perfectly and, more importantly, adapt to any curveballs the real world throws at it. And this breaks down that robot brain perfectly. The eyes are AI models called Convolutional Neural Networks, or CNNs.
Research from Gao and others shows how these can analyze camera feeds to spot microscopic defects a human could never see. And then you have the reflexes. This is where research from Xi's team comes in, showing adaptive controls that can instantly adjust, say, a spray gun's flow rate if it senses the coating is a nanometer too thick or too thin.
So we've got simulation, optimization, and real-time learning all working together. But so what? What does this all add up to? Let's zoom out and look at the real-world impact this has on building smarter factories.
So what's the actual payoff? Well, a study by Wang and his team found that these AI techniques improve the uniformity of the coding by up to 18%. Now I know, 18% might not sound like a mind-blowing number, but in the world of high-precision manufacturing, an 18% improvement is massive. It's a genuine leap forward in quality.
And that 18% jump translates directly into these huge benefits. You get a higher quality, more durable product, you're creating way less waste because you're not making endless mistakes, and all of that adds up to a much more efficient process, which saves time, materials, and money. It's really a win-win-win.
But of course, we got to keep a balanced perspective. The promise here is enormous. We're talking about fully automated quality control, maybe even preventing defects before they even happen. But there are still some big hurdles. AI needs a ton of good data to learn from, and that can be hard to come by. And integrating all these fancy sensors into older factories is a major undertaking. We're on the path, but we're not quite at the finish line yet.
So here's the most important takeaway from all of this. It's not any single one of these technologies acting as a magic bullet. It's the powerful combination of all three. You've got the simulation to see the future, the optimization to find the perfect path, and the real-time learning to adapt on the fly. You put those together and you are building a truly intelligent system that is changing how we make things. Which leaves us with a final question to chew on. We've been talking about product finishes today, but where else could this technology go? What other everyday objects, from the shoes on our feet to the cup we drink our coffee from, could be made absolutely perfect by an AI with its own virtual crystal ball? Something to think about. Thanks so much for tuning in.